These are plastic insulated conductor communication cables, more commonly called PIC cables. PIC cables allow us to communicate next door, across the sea, or around the world. What we're dealing with here is composite sheath PIC cable. Composite sheath PIC cables come in various sizes. 6 pairs, 25 pairs, 50 pairs, all the way up to 900 pairs. Whatever the size, composite sheath PIC cable is made up of an outer plastic sheath, a metal shield, and an inner plastic sheath. This is the core. As you can see, these cables are rated according to how many pairs of conductors there are in the core. In this 25-pair cable, for example, there are actually 50 conductors. When each 2 conductors are matched correctly, the result is 25 pairs. Therefore, this is a 25-pair cable. Pairing is done according to a color code. Because of this color code, you can tell what pairs are to be spliced together. And the same is true for all these cables, no matter what size they may be. The color code remains the same. Let's see how it works. There are 10 basic colors in the color code. 5 ring conductor colors and 5 tip conductor colors. The 5 ring colors are blue, orange, green, brown, and slate. The 5 tip colors are white, red, black, yellow, and violet. Pairs are made by matching a ring color with a tip color. In this first pair, one conductor has a blue ring color. The other conductor, a white tip color. So the first pair has a blue ring and a white tip. Pair 2 is an orange ring and a white tip. Pair number 3 is a green ring and a white tip. Pair 4 is a brown ring and a white tip. And pair 5 is a slate ring and a white tip. Pairs 6 through 10 go through the same: blue, orange, green, brown, and slate. We know they are 6 through 10 because they'll be identified by a red tip. So, pair 6 is blue and red, pair 7 is orange and red, pair 8 is green and red, pair 9 is brown and red, and pair 10 is slate and red. Pairs 11 to 15 use black as the identifying tip color. 11 is blue and black, 12 is orange and black, 13 is green and black, 14 is brown and black, and 15 is slate and black. The next identifying tip color is yellow. So pairs 16 to 20 are blue and yellow, orange and yellow, green and yellow, brown and yellow, and slate and yellow. Pairs 21 to 25 are the last combinations possible. We use the last tip color, which is violet. So pair 21 is blue and violet, pair 22 is orange and violet, pair 23 is green and violet, pair 24 is brown and violet, and the last pair, number 25, is slate and violet. There it is, 25 pairs in the basic color code of all PIC cable: blue, orange, green, brown, slate, white, red, black, yellow, and violet. 10 colors, 25 pairs. But what happens for more than 25 pairs? Let's take a look at this 50-pair cable. Basically, it is just two 25-pair cores, which we just went through, put inside one sheath. There are some differences. In the 50-pair cable, the conductors are divided into 6 units to provide uniform roundness of the core. Each is bound with a color-coded binding string. 3 of these units have blue-white binder strings. Together, the 3 units are called the blue-white binder group. The sum of the blue-white binder groups, 8 pairs, 8 pairs, and 9 pairs, is 25 pairs. So here's one of our 25-pair cores. The other 3 units, also 8 pairs, and 9 pairs, each have an orange-white binder string. So these 3 units together form the orange-white binder group. And the sum of its units is also 25 pairs. So here is the other 25-pair core. You have probably noticed that the binder strings also use the color code. Just as blue-white was the first pair and orange-white was the second pair, the blue-white binder group is the first binder group, pairs 1 to 25. Orange-white is the second binder group, pairs 26 to 50. So you can see that a 50-pair cable is just 2 25-pair cores put together in one sheath. All that's changed is that we've divided the core into units and added some color-coded binding strings to tell them apart. When we get to a larger cable, nothing has changed. All that we have is more 25-pair cores, and each one has its identifying binder group strings. So pairs 1 to 25 are in the blue-white binder group. Pairs 26 to 50, the orange-white. 51 to 75, green-white. 76 to 100, brown-white. And so on, right up to 600 pairs. One difference with this 600-pair cable is that each 2-binder group is wrapped with a white binder. Together, these 2 binder groups, a total of 50 pair, are called a multi-unit. So while the blue-white and orange-white groups make up pairs 1 to 50, they also make up multi-unit number 1. While green-white and brown-white make up pairs 51 to 100, they also make multi-unit number 2. And while slate-white and blue-red make up pairs 101 to 150, they also make up multi-unit number 3. Continuing this particular color coding, multi-units are color-coded up through 600 pairs. Now you can see that it's not so hard after all. All it takes is remembering 10 simple colors: blue, orange, green, brown, and slate, white, red, black, yellow, and violet. The color code provides you with a rapid and sure method of identifying conductors and pairs. An understanding of the color code is the basic knowledge you must have to splice communication cable. PIC.